define an authorization policy, then we'd like to have a way to check that this request is coming from an application owner and not from, let's say, cluster administrator who might not be authorized to make this change to the application. And the way we're thinking to go about this was by doing three things. First of all, basically define a verifiable configuration. So saying this is the set of settings that must be signed in order for them to be applied to the Sidecar containers. For instance, we can say all the mirroring policies must be signed, or all the authorization policies must be signed. The second thing was to have basically a configuration generation tool that we just tried to implement as a prototype. And basically what we did, we took like the Istio testing framework and we reused the Istio libraries to basically translate the content of the CRD into XDS API messages, and then use a signing service such as cosign to basically sign the contents of the policies that we are interested in. For instance, in here, we'd sign these fields for a traffic mirroring policy. Then the second part of the approach, the way we're thinking to go about it, is once we add these signatures to the CRDs, then we'd need to have an enhancement in the Istio control plane to basically propagate these signatures so that they are received by the Sidecar proxies. And finally, the final block is to have a filter in the Sidecar containers where upon receiving this configuration settings, so they're receiving here the XDS API resources, basically then we can check the relevant portions of it, and if this component satisfied can pass the signature verification, then they can be used and they can be applied to the configuration of the service proxy. However, if this configuration doesn't follow the doesn't pass the signature verification, then we could potentially drop it and not apply it to the configuration of the Sidecar proxies. And these are basically the three components that we're thinking as a potential design for verifying these policies.
Yeah, thanks for sharing. I have a couple questions. I'm a bit confused how, I guess, how this all actually works. Because it seems like I don't understand how you can not trust the control plane. Because you may say, like, yes, I applied this RBAC policy, and then it sends me an RBAC policy, and I'm going to verify it's what I wanted. But how do you know the control plane didn't just put that RBAC policy in some filter that's never executed, or that it didn't add a rule in front of it that says, you know, all traffic goes here? Like, unless you're verifying the entirety of the config, it seems like it doesn't matter if you're verifying a small subset, because the control plane can already do whatever it wants. And if you're signing the entire config, then why have the control plane? Why not just, you already know what the config is going to be, so just use that, right? So it seems problematic to me. Like, we're putting a lock on the door, but our window is wide open, basically.
So if the control plane, if policy is coming from the control plane as an XDS API configuration resource, then we are checking basically the incoming messages, and we are identifying the path to those resources.
Sure. So let me give an example, and you can tell me if I'm understanding wrong. So let's say I want to have a policy that says deny all post requests, right?
Okay.
and I want to sign that and verify that I get this policy. And so now as the control plane, I'm an evil control plane. And I'm going to say, I'm going to create a policy that says deny all post requests. And I'm going to put it in a path that is never matched. Like if header matches like XYZ and header never matches XYZ, use this path. It's basically dead code. And on all the other paths, I'm just going to let post requests pass through. I'm not going to put any filter at all. Now I send the message to the sidecar and it says, I found the policy I wanted. Great, this config is sound. I'm going to reject all post requests like I wanted. But in reality, you're not actually rejecting any post requests. That's just dead code, right? How do we prevent that?
Well, so basically, you're saying that a certain policy can be associated with other fields in the messages. And if I check the policy for one set of fields, it might be okay. But if I send it with a different set of fields, then I will, it will.
Yeah, I mean, you can't just look at XGS in isolation. You can't look at just one piece and say like, oh, yes, this piece is fine. It was the one I signed. Because XGS is so powerful. You can do almost anything with it, and there's 100 different ways to do it. It's like if you were looking at like signing Go code, and you say, this must have the function like that I defined here. And then the user is like, okay, I'll go write this function here. I'll never call that function though, and I'm just going to write whatever I want, and it's Go, so I can, it's Turing complete. I can write literally anything. The same applies to Envoy. It can do literally anything. So it doesn't seem reasonable that you could possibly not trust the control plane.
So I looked at Konstantin's implementation, and there's a lot of good stuff in it. So this is a filter that runs in the sidecar. You can eliminate, you can tell it to ignore certain XDS types. So you could say, I never want to hear about mirror policies because I just don't allow it.
But it doesn't matter because I can go implement a mirror policy without using the mirror filter in Envoy. I can, that's one way to do it, but there's plenty of ways to send requests in Envoy.
Understood. So it's a partial trust model, right? You want the control plane to be sending you some updates, like the new IP addresses of pods when they restart. Maybe some other XDSs you don't want, and maybe some XDS types you want them to be signed, so they're only accepted if they have certain types. Now, there's some XDS types that are sort of constructed by the control plane and merged with other things you can't really sign, but others are passed right down, and that's where Konstantin's work does well. If the signature and fields are unchanged, it goes in there and it can be filtered very nicely.
Yeah, I'm not convinced at all that you can have partial trust. It's either you trust them or you don't trust them. There's no such thing as I trust you to provide my RBAC policies, but not my endpoints. I mean, what if I say that now all requests to google.com go to evil.google.com? Like, sure, I signed the mirror policies, that's great, but I've also hijacked all your traffic. I don't see how, like, why do you have an untrusted control plane? Do you not trust the Kubernetes API server either? It seems like a very odd model to me.
The reason is because we have, so if we have an, let's say on-premises cloud deployment, and then, we have then the cluster is running on an application on our infrastructure, but then it might be installed and managed by a third party. It might be installed and managed by basically by a cluster administrator who might not be the same persona as the application owner. And then you have some kind of a trust that needs to exist there between the cluster administrator and the application owner. And that's something that, normally is a big impediment to deploying applications, because it's very hard for an application owner to trust a third-party administrator and believe that they will not try to get their data or,
I don't get how you can not trust the platform. Like, you're running on a Kubernetes cluster, right? Mm-hmm. That cluster, they can do literally anything. They could swap out your images. They can read all your files in the image. They can enter the process. Like, kubelet is root on the node, right? So you have to trust something.
They actually can't in some implementations. So in a zero trust implementation, they can't look at the memory of the process, and they can't look at what is running in the container.
How does that
Right.
work?
There's a secure boot up. It runs in a virtual machine. So people are using this thing with these Kata containers to keep their Kubernetes from being fully trusted. So the Kubernetes administrator itself can't look at a computation that it doesn't want to be output. And we're trying to extend that partially into the mesh. So
But it still controls all the networking, right? They could still have kube proxy, can still say, I'm going to send 100% of requests through my man in the middle proxy. I mean, kube proxy is a man in the middle, right? They can sniff all your traffic. Maybe they can't read your memory, but
right. So
he's just a network proxy. So
so we have Istio doing MTLS. So you can't totally send your traffic somewhere that doesn't, have the matching MTLS. And what we're doing is we're locking down that even more. We're saying, well, we're not going to trust any of these particular types or particular field values in other XDS types. It's not perfect in that you could send to a different MTLS pod than the one you expected, but it's providing more security.
Yeah, I understand your point, but I don't agree. And my opinion is that this is adding an extraordinary amount of complexity, and it doesn't actually solve any. It gives you 1% more trust, and it's either all or nothing on trust, in my opinion. And so I don't think that this is. I don't see this as a good idea, is my opinion. But I've been talking for a long time, so I'll let others talk.
So how would this?
And my recommendation, sorry to interrupt again. My recommendation is, if you want this, then just have something trusted generate the XDS. Don't use the Istio control plane. If you want to trust your XDS and only the application trusts itself, then the application must generate its own XDS. Go ahead, Mitch.
I'm just curious how this would differ from solving the problem using RBAC. So in the situation where you have an application developer and then a third party cluster administrator, and they don't have trust between them, usually the way that you would solve that is in Kubernetes RBAC, setting the sorts of objects that the application administrator can set versus the sorts of objects that the cluster admin can set. How is this different from that?
Well, again, if you have a cluster administrator, then if they have full management permissions to the cluster, they can basically override the RBAC policy.
Okay, I see.
So we really are looking at insider attacks. Now you can have your own trusted Istio control plane, your own private build of that, and you can have RBAC, and you can then trust it. The idea was, cloud vendors, we want to allow the cloud vendor to run Kubernetes and Istio, but anyone could make an Istio that didn't, a custom build of it that didn't respect RBAC. So the idea is, if we put our security not in the control plane, which the cloud vendor provides, but in the sidecar, the agent sidecar, we can run our own build of just that. So Konstantin's whole implementation, or most of it, is this filter that runs in the sidecar that checks for the signatures that are being provided earlier. So the complexity is mostly mental. It's, I have to do these things. The implementation complexity is mostly just there's a few extra lines in the sidecar, and then the signing stuff at the beginning.
Okay, so then how does the sidecar verify the signature? Like if I sign a virtual service, you can run a checksum against that virtual service and see that my key signed the virtual service. But once that virtual service is translated into, say, 15 different XDS configs, how do we verify the signature on those XDS configs came from that virtual service?
So basically, we are using this configuration sign tool that replace the conversion of the CRD into XDS API messages. So given a CRD, we are saying, okay, if we instantiate an XDS server, a fake XDS server or a test XDS server, then it will generate this XDS API resources. And then we take those and we sign their content. And this is how we translate between the CRD and the XDS API messages that are being then signed and verified at the sidecars.
I see. Okay, thanks.
Yeah.
So, John, you were the most critical about this. We really do want to get the ability to run computations where your own cloud vendor doesn't let you see it. Is there any advice you have for Konstantin on the direction he should go on this work that would be, in your opinion, more beneficial to the goal that we have?
The only path that I see forward is to generate the XDS config in your trust domain. So if you only trust yourself, your own app container, then generate it there. And it seems like you're already doing that because you already take the virtual service and then you generate XDS and then you sign that XDS. But then you let the control plane send you that same XDS and verify it matches. So it seems like you already have the XDS. So it just seems like you just want to use it directly.
Well, we like a live Istio because it gives us updates of the pod IP addresses when they restart, for example.
Sure, but if you don't trust it, then I don't see why you would trust those IPs. Or if you really want, then go ask Istio just for the IPs and then locally generate all the XDS. But I don't think that any of this stuff needs to be, like, I don't think the use case of I don't trust Istio control plane is something that is applicable to a wider audience. And I feel like this should be like a custom thing where you go generate all your own XDS as your own app control plane. And maybe it does fetch endpoints from Istio. It seems very odd to me, but it can do that. That's part of Istio API. You can request just certain parts of XDS. And you can have your own little control plane that generates whatever you want on the side. And it wouldn't need any changes to Istio.
I know that Louis was working on a model where one sidecar could pull XDS from multiple control planes and effectively merge that config. And I could imagine a model where you could say, this control plane is the trusted control plane. Here's these sensitive types that I can only take from this one. This other control plane is the untrusted control plane. I'll take less severe or less sensitive types like endpoint slices from this one. But I don't know if Louis has made any progress on that. That was like 1.5 years ago.
There's nothing native, but you can obviously go write a custom thing that goes and fetches XDS from one place, fetches it from the other place, and merges them, right? But there's no existing thing that does that today.
Konstantin and I had talked about an idea where you run, in addition to the agent sidecar, an Istio-D as a sidecar on every pod. What would you think about a solution like that, John?
Yeah, that's basically what I was suggesting. The one downside I would say is that Istio-D needs to have privilege to read all the config from Kubernetes, which may be problematic. So you may, you need to figure out how your local XDS control plane gets its config, assuming it's not all static. But there's various ways to do that, right? You could run another Istio-D that it fetches from. You could give it RBAC permission to read from Kubernetes. There's a lot of options. But yeah, that sounds very reasonable to me. I actually have a example that I set up a few versions back, but I think it mostly applies of doing that for a gateway. It wasn't for trust reasons, it was for a smaller footprint. So you have one single pod that's the gateway in Istio-D. But I can share that with you if you're interested. It's not super hard. It's just, putting 2 containers instead of 1 mostly, so.
Hey guys, I joined a little bit late, so I just want to understand what the thing we're discussing here. So looks like there is a configuration signing tool that is signing the CRDs, and translate the CID into XDS, then how do you validate the signature on the data plane?
I'm sorry, can you please repeat the last part of the question?
My question is after the sidecar gets the signed configuration, how do you verify it? How do you transmit the signing key, basically?
We have the configuration signing tool uses a private security key, and we have the public key on the sidecars.
Oh, okay. So Sidecar has the public key and the signing tool.
Yeah.
And where is the signing tool running? Is it running with?
Signing tool is running offline, actually. We can just feed it the CRD, and then it will generate a signature for that, or an array of signatures, and then those signatures we can copy and paste them into the CRD that we're deploying in the cluster.
Okay, and you put the signature in the XDS message sent to the proxy. Is that how you're doing that?
So basically, we're thinking to have the signature in the CRD to put it under metadata annotations, and then would have a change in the Istio control plane to basically to take the signature from the CRD and add it to the XDS API resource, and then it gets propagated together with the XDS API resource.
Okay, and you want to do that because I believe all the traffic is already MTLS, right, between the control plane and the data plane. And you want to add the additional signature.
Basically, the reason why originally we wanted to do it is because there are cases where the owner of an application is deploying their application on a third-party cluster, and they don't necessarily trust the cluster administrator, that they'll not try to define some policy that they don't intend them to do. So that's why.
I see. So they don't trust the cluster itself, but okay, and they signed using basically the signing tool is controlled in a more like a better secure place. Like the private key is protected.
Basically they don't trust the other people who can define policies and want to make sure that it's them who define the specific policy for their application and not somebody else, if somebody else has also administrative rights.
I see. Yeah, I think the use case actually makes sense to me.
I don't want to interrupt a good discussion, but I think we should move on because we have a lot of topics.
Okay.
I'm happy to sync up with you more
we can
about
follow
this
up
offline if you want.
Yeah. All right. Yeah. Thanks.
Okay. Okay. Thank you for your consideration and for your feedback.
Okay, Shiram, are you here?
Yeah, I'm here.
Oh, perfect.
Hey everyone. This is Shiram from Intuit, and I have Anil with me. He's also from Intuit. So just wanted to talk about one of the like an issue or kind of like a recommendation or whatever. I think during the last release, there was a feature that we implemented. We kind of extended enabling TLS on Sidecar proxy. I can actually share my screen here. hope you can see my screen. Yeah, so in order to do that, we kind of extended the Sidecar API. Sidecar API's Istio Ingress listener to include the TLS configuration. After adding this, we were able to perform both one-way TLS and MTLS from outside the mesh. So this was working, but then while we were implementing this, things came up like how this would interact with peer authentication set, either on namespace level or on the mesh level. I think we talked to John about it during the implementation, and during our conversation, I think we kind of decided that for our first iteration, we would need a peer authentication config that would set on the app itself, would have to disable peer authentication on the port that we are allowing TLS on. So reason was we did not want plain text, because I think the default peer authentication is permissive. So we did, but when we have TLS set on the Sidecar, we did not want any plain text traffic to be allowed. Yeah, so in that case, we kind of use this config to disable it on the port. But then after the implementation, we kind of, I think Facila also brought this up because they also wanted to use this feature to do MTLS from outside the mesh. Adding this additional config of peer authentication kind of adds like a little bit of confusion, because first it says disable, which is not at all intuitive as to what's happening, and adding additional configuration kind of increases the complexity. So we wanted to reduce this complexity, remove peer authentication. I think when I created this issue here, there was a lot of good feedback coming from, I think, I don't know how to pronounce this gentleman's name here, but and John's feedback as well. I think we also suggested, I think, provided 3 different solutions. One was to ignore peer authentication if TLS is set on the Sidecar. We would take TLS as the TLS on the Sidecar configuration takes precedence and ignores the peer authentication. That was solution 1. I think John mentioned that the solution would not work because there are different personas working on it. So that would not work. Then I think the second solution was to add another mode, kind of like external TLS. But that doesn't help much, because it still requires us to configure a peer additional, like a configuration of peer authentication here. And the solution 3 was to move the TLS setting, which is currently on the Sidecar Istio Ingress listener, move that to peer authentication itself. So this keeps it in one place, and then we don't need an additional configuration. So that was the 3 solutions here. So I just wanted to bring that up and share it with the larger audience here, so that we can discuss and see where if we can come up with like a consensus of which solution, or we can or come up with a solution here. So do you guys have any feedback?
My one feedback would be that I think the option, I forget which option it was, sorry, but that like a lot of things look at peer authentication, both in Istio as well as external tools. And so if we do the one that like kind of overrides peer authentication, I would be a bit concerned about that, because we may break those tools and or that code. I don't see anything particularly wrong with option 3, putting it in peer authentication. Yeah, I don't know. It seems, it feels like I should be able to come up with a reason it's a bad idea, but I can't. So I don't know. Lehman, do you have any issues with that? I mean, it is kind of weird that the field's called port level MTLS and then it's not MTLS.
I mean, other than backward compatibility as mentioned?
Well, it is a new field, right?
Yeah, sorry, I'm still trying to catch up. So the proposal is to add what field to the?
The proposal is to add TLS configuration to peer authentication. Basically, right now the config is inside the steering risk listener inside the Sidecar API. So the proposal is to move this to the peer authentication itself, so that we don't have to configure these this in two different places.
Oh, okay, I see. So you're moving the configuration from Sidecar, right, to peer authentication.
Yeah, one thing to
Yeah.
mention too, that Sidecar config was brand new in 1.13 and it's hidden from docs and marked as like super experimental. So like backwards compatibility and moving it is not a major concern, I think.
Yeah.
Okay.
Yeah, I think that's probably a good idea. So we have one single place to specify the TLS configuration instead of having two places.
That's correct. Yeah. Okay, so this issue is still open. So if you folks have any other feedback or any concerns with this solution of moving it to peer authentication, please feel free to add it. I think there are only 20 minutes left, so I don't want to take any more time.
Thanks. I think option 3 makes most sense, but I'll take a closer look and make sure that I still think that after thinking about it for a long time.
Cool. Awesome.
Does that work for
Thanks.
you guys as well?
Yes, it does.
You have no
Yeah.
issues with that? Okay.
Yeah. Great. Thank you.
All right. Up next, we have Auto S&I.
Hi, I also won't take much time because there are more items left in the agenda. So I have created this RFC for auto SNI and auto SAN validation in destination rule. I think John has already started reviewing the RFC, and it's a very simple one. So I would request everybody else to do an offline review. No need to present it for right now because it's quite simple. I think the use case already had interest in the community because I already see an API PR for the same, which was done like an year ago, but there was no activity on it afterwards. So I would like to resume the task from wherever it was left and take it to completion. So it would be great if others also can do an offline review of the document.
Okay. That sounds good. My 2 cents is that generally I think it's a great improvement. So
Thank you.
the main things I think we'll need to figure out is whether we have an API for it or if it's just automatic.
Yeah, that we can discuss maybe on the RFC itself as comments. We can continue the discussion.
Sounds good. Doug, I think you're up next.
Okay. Let me see if I can present. Did that work? Let's see.
Yep, I see it.
Great. Yeah, so this is a proposal related to the Telemetry API. For those of you that are somewhat familiar or maybe not familiar at all with Telemetry API, there are really 2 parts, right? So there's the configuration of telemetry behavior, and then there's a reference to a provider. And right now, all that provider config is defined in the mesh config itself in this extension providers section. And so we've had a number of requests to improve the user experience around extension providers. And so this proposal is a proposal to deal with those requests in a way that's extensible and doesn't really change much about the setup, the breakdown between extension providers and Telemetry API. So at the high level, it's really, we want to expand the provider ref message, the schema there, to support the ability to reference custom resources as well as services directly. And then there's a third sort of separable proposal, which is that if we have that support, introducing a custom resource for like stream-based access logging, so that you can configure different access logging parameters without having to change mesh config. And so I have a couple of use cases in here of what this might look like that we can go through if there are questions. So this one right here is if you wanted to change the format of your local access log, you could create in your namespace a local access log configuration and then point to it in a telemetry resource and saying, okay, for anything that has a response code greater than 500, log it in this fashion. For the direct services one, what we need is a type, and then this uses sort of the backend object reference from the gateway API schema for selecting that service. So you could say, for tracing, I just want to use this Jaeger instance here based on this service definition and point at it. So that's really the extent of this proposal, is just to see if what people feel like in terms of, is this something that's worth pursuing? And then, we can figure out the sort of naming and details on that later. So I'll stop talking, and I don't know. I just want to share this and get comments, feedback.
Any comments? Otherwise, I guess we can just review this one.
Yeah, how do we avoid the old Istio meme that we have 50 CRDs and Istio sucks because it's so complicated?
Well, by not defining all the CRDs ourselves, right? So I think we would start with maybe just the file access log one, and then say you can point at services, which is mostly what those extension providers are, right? They're really just names and services with very little extra config. And then we say if other other open source projects create their own custom resources, we can slowly add support for pointing at those if you're already using them. But we won't own defining the Zipkin CRD or the Jaeger CRD or the Datadog CRD, right? That's something that we just won't support. But if others define them, then we will have the ability to point at them.
But don't we still need to be able to configure those in the meantime until they define those?
Yes, but I think we can say that the way to do that in the short term is you point at the service for them, and that's the extent of the configuration we support. And if you need provider specific config that isn't that service and things that are available from Istio APIs that impact calling services, then that should be done. Then you have to use mesh config, or we don't support it. Would be my.
I get what you're saying. It seems a bit concerning to me because one, that means that we have to support mesh config indefinitely, and we have two ways to configure the same thing. And if we don't do that, then we lose config until these third-party things provide their own CRDs. But I haven't seen any evidence that any of these integrations ever plan to add CRDs.
Right, and so if you look at them, the configuration is name and port, right? Service name or service address and port, and then a name for all of them.
I mean, they all have that, but they also have more, right? Like X.Z has package bytes, allow partial message. We have max tag length. We have all these other things.
Looking at the tracing one, so this doesn't cover X.Z, right? This is not
Okay.
This is not for authorization policy, and I think it would be nice if they had a similar one, and I'd be curious what their policy is. But for telemetry, the tracing ones, I just looked, we can promote max tag length, and then it's the access tokens is basically the only other thing that the tracing providers use. Logging, I think we can move some of that format stuff up and use maybe one or two CRDs. There is already logging CRDs that have been defined by other mesh projects, and we can think about supporting those instead of defining our own. And then metrics, there isn't anything that really needs configuration in that way. from Prometheus or Stackdriver, which are the two that we support anyways at this point.
Okay, I would say I think there's a big difference between importing a Zipkin CRD and an Ambassador CRD. I would not be in favor of doing the latter.
I mean, that's fair, right? We could, yeah. So I think the question is, can we define some limited set, like a couple of logging ones, and have that be enough? And I mean, would love to hear someone saying, strongly one way or another on that uses some of the other integrations. I mean, putting it in mesh config is not ideal for a lot of reasons. One, it makes it somewhat inflexible in the sense that we have to, you have to have access to mesh config, which people might not have access to. And having some extensible way around that would be nice. I don't, I thought through lots of different ways. This is the one that is currently what I'm favoring, but I'm open to other suggestions or other approaches.
Have we considered just inlining the entire provider in telemetry or allowing that?
Well, so I mean, that was the shape of the original proposal however many years back, right? And then we decided to split them.
Right.
I think we could consider it again. Makes me nervous to start over.
It does make me nervous as well. I don't necessarily like it. I was just wondering if we had.
I mean, in some sense, that service reference with a type is sort of doing that. It's just saying that, because you could then maybe even add another field, which is some sort of structured config of typed config, sort of like the Envoy style. So maybe this is the gateway drug to that. I don't. I guess I would like other opinions on that, so that I don't feel like I'm operating in a vacuum there. So I'm just hoping other people would have comments, but if not, we can wrap up and I'll just say, please take a look at the doc and comment. Let me know. I'd like to move forward on this while it's still in alpha, so we have an idea of the approach before we start trying to stabilize the API approach. And then maybe we can look at also trying to do something similar for our authorization policy if we like what we end up with. So. Yeah, so John, maybe you and I need to hash it out offline, but
I don't have good advice right now. Like, there's some part of me that thinks that doesn't like this, but I don't have any concrete reason why or a better idea. So it's not very constructive at the moment.
Okay. Well, it doesn't sound like we're getting any extra feedback here, so I'll defer to whatever the next topic is.
That would be John.
Okay. Yeah, I'll think about it some more, Doug, and we can talk. I may just be in a no mood today.
Fair enough.
All right. I guess I can just take over. So I want to talk about a proposal to kind of change how we handle external name services. Window. Okay. So for some background, external name service looks something like this. This is a Kubernetes thing. So you say that my service, which is named here be external, is actually for this external name, which is another host name. This could also be something like google.com. And what this would allow you to do is to say something like curl be ext, and it would actually go to this address, which could be google.com or something else. So it kind of allows for like legacy migrations, like, maybe you make a DB external name service and it points to some AWS instance. So the problem is that we implement this totally wrong, basically, and that causes a lot of problems. If there's been a number of issues reported. I tried to list them all here. You can see it's quite large. Some of them are quite bad, like breaks out going HTTPS connections, incorrect config, hijacks all traffic on the port. So there's a lot of issues. And kind of the root cause is that the way that Kubernetes implements this is completely different than what we do. So in Kubernetes, this literally just creates a CNAME record in the DNS. That's all it does. Port is not used at all. Nothing else changes. It just means that if I look up in DNS bxed, I get a CNAME for this service instead. But what Istio does is it actually creates like a whole service where you create an Envoy cluster. We use the ports as part of that. We do this matching on host header, SNI, or port for TCP. And what ends up happening is that you get totally different behavior when you use Istio. So my goal here is kind of to make it so that with and without Istio, you get the same behavior. And the Istio behavioral changes are only for things that are intentional and actually improve the user experience, not just because we happen to implement it differently. So my proposal is to kind of change our implementation to much more closely match Kubernetes. And how that would work is we essentially treat these like aliases. So we don't control DNS, but what we would do is quite similar in that anywhere that we would have matched the other service, so in this example, anywhere that we would have matched B, whether this is a host header or SNI, we will also match the alias for it. So we'd also match bxed. And then we would send it to the same service. And what this means is we also don't use the port. It behaves very, very similarly to with Kubernetes. And you largely get the same behavior. Now, there are kind of 3 caveats to that. One is obviously this is behavioral change, so we'll need to handle rollout and breaking change, migration, docs, all that stuff. But the other 2 are kind of more fundamental. Is if we do this alias thing, then we no longer have like this external name service as its own independent thing that can be referenced and configured differently. So I can't say like for like in this example, for google.com, use 5 retries, but for Google, the external name alias, use 10 retries or whatever, or a different destination row config or something like that. So like these are truly now the same thing. I think that's probably fine, but that is one caveat. And one of the reasons I think it's fine is that largely our intent with support for external name is to support people that are taking an existing Istio or Kubernetes cluster, and then they just use they just add Istio to it. And so I think we should prioritize maintaining the existing behavior. And if people want to do custom config for these services, they can use Service Entry, which already does it. And so they're still enabled to do it. The other issue is that if you actually do like explicitly forward to this Google service as part of like a virtual service, especially at like a gateway or something, like we don't have a cluster for Google. And so we might have a cluster for the referred service, google.com, if they defined a service entry, at which point we would just kind of resolve that alias and forward it there. But if there was no service entry for google.com, then this would no longer work when it previously did. So I tried to look at what other Ingress implementations do for external name, like referring to an external name. And it's very, very, very murky. I could not find 2 implementations that did the same thing. Some of them just don't work at all. Some of them do DNS resolution and send there. Some of them have flags to do different things. So there's not really any standard. Yeah, that's basically it. I talked a long time, and I don't know if it made any sense. So feel free to ask any questions. Does this seem like something that's desirable, worth pursuing?
Sorry. I'll take a look at this. None of our users actually use external name in this capacity. Like we don't recommend it because it's, but yeah, I mean, I'm I'm okay, at least like on the surface of, you know, us making it better. So I think that's kind of how we should operate anyway, right? So external name, I know it kind of has some like hacks within the code anyway. So
yeah, my
yeah.
expectation is kind of that, like, if you're using Istio already, you're probably not using external name because it's totally broken. And so we won't impact many Istio users. And if you're not using Istio, then you adopt Istio. If you're using external name, you'll probably be broken because it's broken in Istio today. So this seems like for the vast majority of users, it would be beneficial output.
Yeah, I was going to say, I think it would make sense to fix.
Okay, cool. We don't have time to discuss the other one, but last week I had a broader proposal that was similar in goal of make things behave more like Kubernetes, but still, you know, add benefits of Istio, obviously, but kind of holistically doing it across the board instead of just external name. I don't think we have time to discuss it here, and I don't think a lot of people we need to discuss it are here, but please take a look at the doc if you haven't already. It's on the meeting notes right after this one. Thanks,
All right,
everyone.
thanks, John.
I think that's all the agenda. So, and we're out of time. So unless there's any last minute things, then we'll probably call it a day.
All right. We will see everybody next week, and we'll see about if we'll have another time zone meeting as well.
One more thing I wanted to say, I was not able to access the last week's recording. Can somebody help me to understand where exactly it gets uploaded?
I think Mitch fell off, and I want to say Mitch was the one who recorded it last week, so he might know where they show up.
Okay.
Do you know, John, when you click record, does it actually get sent to you, or does it show up somewhere and we just have to move it to YouTube?
It gets sent to one person, and that person might be Mitch. I'm not sure. I think Mitch already left. I'll message him offline and see.
Sure. Thanks.
All right, see you.
All right, thanks. Bye, everyone.
Thank you.